Welcome to Brain Vision.
Right off the bat, we know that density is equal to mass over volume. Okay, so what is change of density equal to then? Well, delta rho is equal to density final minus density initial. And that must also be equal to mass over our final volume minus our mass over our initial volume. We also know the volume expansion equation, right? So this becomes m times 1 over vi 1 plus beta delta t minus 1 over vi. We can factor out vi's to get m over vi times, and then, create one big fraction here in the middle, times 1 minus beta delta t over 1 plus beta delta t. These ones will cancel, and we are left with delta rho is equal to, well, m over vi, we said before, is just initial density times negative beta delta t. And because we're looking at such an infinitesimal small change, this is just going to be essentially 1 because this is going to be 0. So we are left with the desired expression, delta rho over rho initial is equal to negative beta delta t. Okay, now why is there a negative there? Well, this is kind of a very calculus-oriented way of looking at this question. The negative there tells us that as temperature increases, our density decreases. This makes sense because we know that based on volumetric expansion, as temperature increases, volume also increases. And because density is mass over volume, density must increase. So I'll just send it up as a delta t up, delta rho down. Okay? Now, what if we have an initial of 1.0000 grams per centimeter cubed at initial temperature of 4 degrees Celsius, and we had a final density of 0.9997 grams per centimeter cubed at a temperature of 10 degrees Celsius. Well, we can just plug these numbers into our equation, right? So delta P is final minus initial. It's going to be 0.9997 minus, I'm just going to say 1 there, over our initial, which is 1, is going to be equal to negative beta delta T is 10 minus 4, and solve for beta and get our beta equal to 5.0 times 10 to the negative 5 inverse degrees Celsius. Okay, last part, part D. What if we have an initial density of, again, 1.0 grams per centimeter cubed at initial temperature, same thing, of 4 degrees Celsius, and this time we have a final density of 0.9999 grams per centimeter cubed at a final temperature of 0 degrees Celsius. Again, plug it in for our equation, so our delta rho is going to be 0.9999 minus 1 over rho initial, which is 1, equal to negative beta delta t, 0 minus 4. And you should find that beta is going to be equal to negative 2.5 times 10 to the negative 5 inverse degrees Celsius.